Hello class, here's some helpful hints to get you going on problem number 3 from the workshop. This is a pretty tricky problem. There's actually a couple different ways to go about solving it, but I'm going to show you the way where we look at each block individually, setting up some of the forces for each block as the problem asks us to do, and then using that information to find the acceleration of our system. So if we look at our drawing here and read the problem statement, we know that we're going to be releasing this 9 kilogram block, which will cause it to accelerate in the downward direction. And if it accelerates downward, then your 4 kilogram block will accelerate up the ramp, and your 6 kilogram block will also accelerate up the ramp as a result of the pull force coming from the 9 kilogram block. And so what that means is you're going to end up with two different tension forces. You're going to end up with a tension T1 between your 6 and your 4 kilogram block, and a tension T2 in the rope connecting the 4 and the 9 kilogram block. So what you see here is that on this problem we actually have this situation where there's 3 separate blocks and there's 3 different things that we do not know the value of. So what are we going to need to do? Well, we're going to need to somehow come up with 3 different equations to solve for our 3 different unknowns. So let's go ahead and start by drawing free body diagrams for each block. I'm going to start with the 6 kilogram block, since it's the first one on the left, and I'm left-handed, just kidding, okay. But I'm going to start with the 6 kilogram block. So what forces are acting on it? Well, we can see that tension 1 is pulling it up the ramp, so that's T1. We also know that it's going to have its weight force, which is going to be straight down. Weight force is equal to mass times gravity. So I'll call that m6 times gravity g, and then we know that it's going to have a normal force perpendicular to the ramp. So we'll call that force normal 6. So once we have that set up and established, we're going to need to go ahead and label our axes. So I'm going to call this the y direction, perpendicular to the ramp, and this the x direction, parallel to the ramp, so x and y. And as we've seen in class and in homework, we can identify this angle here as a 30-degree angle, the same angle as the ramp. So there's the 6 kilogram block. Now let's move on to the 4 kilogram block. It too is at an angle on the ramp. I'm going to move it down to give myself a little more space. So it too is on an angle on the ramp. The forces we see acting on it, it has T1 acting on it, but it's actually pulling it down the ramp. Then we have the normal force, F normal 4. We're going to have T2 pulling it up the ramp, as we can see in the image. And then, just like with all things on Earth, it has its weight force in the straight down direction, which we can call M4G. So once again, let's go ahead and label our axes. Here's X, parallel to the ramp, Y, perpendicular to the ramp, and here's our 30-degree angle. And then lastly, we can look at the 9 kilogram block. It's going to be a little simpler because the only forces it has acting on it is its weight in the downward direction, M9 times G, and it's going to have T2 pulling up on it. And again, just to remind ourselves, we must not forget that the acceleration on this 9 kilogram block is in the downward direction, whereas the acceleration on the other two are up the ramp. Okay? So at this point it looks crazy and fun all at once, and what you're going to need to do is go ahead and now write out some of the forces for each of these different blocks individually. I'm not going to do all of these for you, but I am going to help you with 2 of the 3. So, some of the forces in the x direction for the 6 kilogram block. I'm going to leave that one to you guys, but we do know it's equal to MA, where this M here, we must pay close attention, is the 6 kilogram block. Because notice, we have M for the 6, for the 4, and for the 9 kilogram block. Each of those M's have different values, and so you must make sure to keep organized with your subscripts or just plugging in the actual values for them. So that's the 6 kilogram block. You're going to use that, and I'm going to leave it to you. So I'm going to help you with the 4 and the 9 kilogram blocks. So some of the forces in the x direction for the 4 kilogram block will also be equal to its mass multiplied by the acceleration. Now notice, I'll mention this a bit later here in a minute, but both of these two accelerations are positive because the blocks are accelerating in the positive x direction. That will be different over here when we get to our 9 kilogram block. So what forces are acting in the x direction? Well, we can see from our drawing up there that we're going to have T2 in the positive x direction. So we're going to have T2. Then in the negative x direction, we're going to have T1 minus T1. And then also in the negative x direction, if we go back up here to our picture, you can observe that there's also a component of our weight force here in the negative x direction. And that component should be equal to m4g multiplied by the sine of our angle 30 degrees. So that too is in the negative x direction, so we're going to have minus m4, which is just 4 kilograms, multiplied by g, 9.8, multiplied by the sine of our angle, 30 degrees. That S is really bad, so I'm going to rewrite it. Alright, and so all of that we can observe is going to be equal to m4 multiplied by our acceleration A. So as you can see, we have one equation with 1, 2, 3 different unknowns. Oh boy howdy, right? So now we're going to have to go ahead and move on to our 9 kilogram block to try to get another equation to help us solve. So in this case, some of the forces in the y are going to be equal to mass multiplied by negative A. Why did I say negative A? Well, if we go up here, notice in order to keep all of our objects accelerating in the same direction as we drew up here, they're all accelerating in the same direction, that must mean that our 9 kilogram block is accelerating down in the negative y direction. So when we do some of our forces in the y direction, then we can see that in the positive y direction we will have T2 pulling it up. Then in the negative y direction we will have, switching colors here, we're going to have negative m9 times g, which is 9 kilograms times 9.81, and that's going to be equal to our 9 kilogram mass multiplied by negative acceleration. So from here, you should be able to solve this for T2. Once you have a value for T2, you can then go ahead and plug it in up here where you see T2. Similarly, when you finish with your 9 kilogram block, or excuse me, with the 6 kilogram block, some of the forces, you should get a value for T1 equals to something, and you can plug that in as well, and you'll end up with one big, beautiful / ugly equation that only has acceleration as a variable once you've plugged in all your unknowns, and you can go ahead and solve. So good luck. Let me know if you have any additional questions, but I hope this helps you get started on this fun and tricky problem.